Good day, I'm Maile Madziba. Welcome back to our channel. We're continuing with our 2017 study guide. We're looking at example 3.1. It says use the formula U equals to 1,08k over Cp times rho as discussed above to calculate U in meters per second if K equals to 0.1 watts per meter Kelvin and Cp equals to 5.2 kilojoules per kilograms Kelvin and rho equals to 1200 kilograms per meter cube. Now, they say as discussed above, and we know that actually this is an empirical equation from the equation we got before this example from the study guide. And another thing we know is that an empirical equation can only be used when the values plugged in have specific units. An empirical equation is always designed for specific units. And for instance, in the case of this equation, we know that let me just write it down. We know that the equation is valid. Let me just write it down. We know that the equation is valid only when K is in BTU per feet hour degrees Fahrenheit and Cp in BTU per pound degrees Fahrenheit and rho in pound per feet cubed. So these are the only permissible units that you can actually use in this equation, or the values of the units that you can actually use in the equation. And now when you check the information that we're given, we realize that our K is actually in watts per meter Kelvin, our Cp is in kilojoules per kilogram Kelvin, and our rho is actually in kilograms per meter cubed. So our first task would be to convert each of these into these units. So we can say step 1, convert K, Cp, and rho into the units for which the equation was designed. I think I've said it clearer. Yeah, for which the equation has been designed, and these are actually the units for which this equation has been designed. Now with that said, we can just start with our K. Therefore, K equals to 0.1 watts per meter Kelvin, and we know, that W or watts equals to joules per second. Therefore, our K is equals to 0.1 joules per second meters Kelvin. So that is actually our K. We just replace the W with joules per second because we know it's watts. So with that said, now we're converting this, and these are actually the units that we're pursuing. So we can start with our J, which is our joules, and we know that 1 BTU equals to 1055 joules, something that we know. And then we come to our second. We know that 1 second, we know that 3600 second equals to 1 hour. And the reason is we know that the equation we're pursuing have an hour instead of seconds, so we're converting from seconds into hours, and this is the ratio. And now we come to the meters. We know that 0.3048 meters equals to 1 feet. So now we're left with our Kelvin. We also know the ratio of Kelvin. We know that 1 Kelvin equals 1.8 degrees Fahrenheit. Now this gives us an answer of 0.05778 BTU per feet hour degrees Fahrenheit. So I can just cancel out a few and just to see if it correlates with our units. We know the joules fall off. We also know the seconds fall off. We also know the meters fall off. We also know the kelvins fall off. So with that said, above here we only left with BTU, which is here, and underneath we know we left with hour and feet and degrees Fahrenheit. So this confirms our units. So this is actually our K. Then we come to our CP, which is our heat capacity. We know that our heat capacity is actually 5.2 kilojoules. We can write it as 5,200 joules per kilogram Kelvin. Yeah, well, I think I didn't really need to do calculations. I believe it's easier to notice that a K in this case is actually 1,000. So we just multiplied by 1,000, the 5.2, and then it's 5,200. I hope it's easy, even if I didn't explain it in much more detail. So now we're pursuing our J like we did 1 BTU. Remember now our CP, this is actually the units we're pursuing. It's BTU per pound degrees Fahrenheit. So we're converting our joules into BTU. We know 1 BTU equals to 1055 joules. And we know that our kilograms, we know full well that 0.4536 kilograms equals 1 pound. No, we converted our kilogram into pound. Now we know also our Kelvin. We know that 1 Kelvin equals 1.8 degrees Fahrenheit. So with that said, this gives us a value of 1.2421 BTU per pound degrees Fahrenheit, which are the units that we're pursuing. Now, just to do a few cancelling out, just to confirm that our units are actually consistent with what we're calculating. Yeah, and also the Kelvin falls out. Above, we know we left with the BTU, and underneath we have pound and degrees Fahrenheit. So that actually confirms our values. So we then come to our rho, which is our density. We have rho equals to 1,200 kilograms per meter cubed. So what we're doing now is that we're going to be converting our rho or our kilogram into pounds, because let me just bring the original question you see. These are actually the units that we are pursuing for rho. It's pound per feet cubed, and we have kilograms per meter squared. So we're converting the kilogram into pounds. We know that 1 pound equals 0.4536 kilograms. Now we're converting the meter cubed. We know that 0.3048 meters equals to 1 feet, but it's cubed. So yeah, that again is high school mathematics that I believe by now we understand it clearer. So with that said, we get an answer of 74.9223 pound per feet cubed. And also just to cancel out in confirmation, we know our kilograms falls off. We also know that meter cubed here, if we cancel the meter here, then we cancel the meter cubed because it's cubed, and then the feet is going to be feet cubed. So we have pound per feet cubed. That also confirms our units. Now with that said, this takes us to our step 2. Remember that this is actually our step 1, and let me just bring that one. Our step 1 was saying convert K, CP, and rho into the units for which the equation was designed, and now we're done with converting the 3 of them. So now we come to our step 2. Let me just write here that step 2, calculate U, right? So we're calculating U because the equation says calculate U, but it says in meters per second. So I can just write calculate U, and now we know from the equation that U is equals to 1.08 K all over CP, all over rho by CP, or CP over rho, it doesn't really matter. So that is actually our equation, and we know that because it's an empirical equation, it has specific units, but we did all the job of actually converting from the actual units that we have been given into the units that we needed to convert them to. So with that said, we are very much free to use the equation. However, something that is very much important I need to highlight is that it's important to understand that when you use actually the empirical equation here, you don't need to also use the units because it doesn't really have units consistency. With that said, if you plug in the units here, the units won't actually arrive here. Let me bring, yeah, they won't arrive in, where's that one? Let me just bring the other one. Yeah, it won't give you the units of this. Is actually, the value that you get here is actually feet per second. And if you, oh yeah, this is the paper. So U is in feet per second, which means if you use this equation with these units, the number you get, it has units of feet per second. So it's important to understand that if we use all these values, if we use like these values with the units and plug them in this equation, there won't be unit consistency, which means at the end you won't have feet per second. And that's why it's called an empirical equation. With that said, it's wise to understand that when we're going to use this equation, we're going to use the values and not necessarily the equations, or rather the units. And at the end of that value that we get, we know that value has units of feet per second. That is just a general rule that we need to in understanding all this. So with that said, we can say U equals to 1.08 times K. We calculated it to be here. It's 0.05778. Also, don't forget to leave out the units. All over our rho. Let me just check out our rho. Our rho is, where did we calculate that? Yeah, here's our rho. Our rho, I just misplaced the page where we calculated it. Rho, oh here, our rho is actually, sorry about that, it's 74.9223. Also leave out the units. Multiply by our heat capacity, which is our CP, is 1.2421. So now this gives you a specific value, and if you use your calculator, you will realize that the value that we get here is actually 0.0006671 feet per second. So that is actually our U, but remember originally they told us that calculate U in meters per second. So now we have U in feet per second. This takes us to our step 3. Step 3, convert feet per second into meters per second. It shouldn't be difficult. Now I need to highlight and understand that now that we're done with the empirical equation, it's important to understand that our conversion here now is going to need units in it. So which means we're gonna be saying U equals to 0.0000671 feet per second, but to convert from feet per second to meter squared, we know full well that 1 meter is 0.3048 meters, or rather 0.348 meters equals to 1 feet. Yeah, so that is basically how to go about it. And with that said, we know that the feet is gonna fall off, and then we are left with an answer of 0.0002044 meters per second. So that is actually our U, and with that said, we have actually answered the question completely. So thank you for your time. I hope we meet again in our next video.